In this video, we are going to look at how to procedurally generate a new curve based on two source hand-edited curves using geometry node in a non-destructive and dynamic fashion. So let's do a quick demo. These two original curves are, let's say, they could be hair guidelines or row system that you are making in your grand procedural project. Let's say we want to quickly generate a children that can blend between those two, right? Can help us tremendously in other projects. And we can conveniently pick the source mesh and the weight between the two parenting original source, right? And as you can see, the node is rather simple and we can do it from scratch together. First of all, let's hide our previous object and add the default cube. Let's put it in the center of the world, yep. And with that, we can create a new geometry node. As per tradition, let's get rid of our default cube and we can start our new thing. So what we first need is some way of sampling the two original mesh, right? So let's put in a object info node, and with its name we can choose our curve A, which is the original curve on the left. And we can do the same for the right, but we can also do is go to the outliner, click on our curve B and drag it in. Let's preview what we actually got from doing so. Join geometry, plug it in there. So the default setup for object info is set to original. And as you can see, it reproduces the curve with respect to its local position, meaning the origin, right? So this orange point is as if the orange point becomes the orange point of our cube. Okay, this is fine, but not so interesting for our application. What we actually want to see is the source position of the curve and their relative positioning, right? The gaps between those two. We are not interested in this new gap that has no meaning. We want to be contextual to what has already been there. And if you try to toggle the object info node into the relative tab, you see it respects the relative position of those two curves. It really shows what we are interested in, which is the spatial separation between those two curves as they were, not as a new version of themselves, right? So this is a step to the right direction. These two info nodes help us capture some semblance of that geometry. But what we really need to do now is to create a new curve. So let's join it and preview what it looks like. By default, this new curve has only two control points, right? If you look at it like that, only two control points, 0, 0, 0, which is the bottom one, and 0, 0, 1, which is on top. And you can see in the native data structure, it is assigned two index, right? So 0, 0, 0, this has the index 0. And 0, 0, 1, this guy, this control point has the index of 1. Nice. But if we want any form of deformation or curvature to it, we're gonna need more points. So that's simply achieved by placing a resampled curve node. So now, if I mute this and toggle it back and forth, you see our simple curve with only two control points has now become a new curve with the same shape that has 10 control points, and the index is 0 to 9. So let's erase this. And, oh, I didn't draw over it actually. Yeah. So now it has become a new curve with more points in between, like 0, 1, 2, all the way, dot, 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 to 8, and then 9, right? It should be enough for us to do some basic deformation. Then comes the problem where we need to figure out how to transfer positional data from one curve to another, right? From our old curve to the new one. And usually with transfer attribute or capture attribute, usually it's fine and dandy to use nearest face interpolation. It relies on your old and new geometry being similar in shape or proximity, right? It's like you can project something from the low poly to high poly, that kind of logic. But as you can see, the two curves are not similar in any ways, right? They are not similar in number of control points, they're not similar in shape, and they're very far apart. We can make it so. We need to create certain similarities between them. And what we just did with the resample curve, let's try it on our new guy. I mean on our original curve, curve A. So now, curve A, if we preview that, previously curve A has like 14 or any arbitrary number of your hand tweak curve, doesn't really matter. As long as we pass it through a resample curve, like that, and then we view this. Yep, there you go. So if I mute, see the original has 15 control points, and if we resample it, there's only 10. Nice and simple. Just like our new curve, right? 0 to 9. It is assigned an other value, which is, again, the curve A control points are named in this way, right? 0, 1, 2, all the way dot 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 to 8 and 9, right? So it does not matter right now that they are very different in shape. We have a new type of similarity, which is the naming system, right? The vertex indexes ordering. It's the same. If we can use the same name and transfer positional data of vertex 0 and curve A to vertex index 0 on our new child curve, then we have solved our problem. We get our desired product. So let's actually try that. With the transfer attribute now set to index, right? We are not interested in interpolation because the two mesh are very different in shape. So let's first preview the new curve, right? We make sure our new curve still the way it was after sampling. So first of all, we need to make sure we're transferring a vector because we're interested in XYZ coordinate, which has 3 values, and we need to use vector. And the source will be our curve A, right? This guy, curvy one. Hand groom, arbitrary number of vertices, now resampled to a 10 index system. Then we are interested in its positional data, this vector, blue on blue, correct? Now we have successfully captured this number per indices, yes. Afterwards, we can use a capture attribute on our new curve, right? Because our new curve wants to capture a new attribute. And we need to change it to vector again because float is only one number. But XYZ value is a bundle of 3 numbers. So there you go. 3 numbers. Then our new curve has successfully captured the positional XYZ values per indices. So now our vertex index 0 knows I can reference the XYZ value of this guy. Number one knows that I can reference the XYZ0 of that one. But yet the shape did not change because capture attributes only let them know about it. But you're not making it do anything with this new data. This new data is just output along with our geometry, right? So this is the knowledge. This is the guy. We need to make this guy do something with our knowledge, our newfound knowledge of the XYZ position of the old curve. So we can take action by doing set position and plug in the attribute. Yeah, so now you see our child curve just jumped to the new position, right? You see? So that's perfect. What we can do now is tidy it up a little bit. For example, these three nodes, we can join them in a frame. Organize the input and output a little nicer. And we can duplicate this whole setup because we are gonna have to do it with the second source curve, right? So we again will resample it 10 times. Then this will go into the source. We're capturing its position per index on individual points, right? After that is done, we can take our baby curves who capture the first set of attribute, come over here, capture the second set of attribute. And now if we plug that in, and yeah, that's our new baby curve. Now you see the new baby curve is forced to go to the position of curve B based on index, right? To recap just very quickly, curve B also has the nice indexing system because we resampled it. So for curve B, there's also this 0, 1, 2, all the way to 8 and 9. Right? No matter the original setup for the curves, we have resampled it. So now it's unified between three curves and it's nice and fine. And what we did here, plugging the second set of attribute into the set position, we are telling this vertex 0 to go to the vertex 0 of B instead. So what it's doing is that 0 go to 0, 1 go to 1, and 9 go to 9 all the way, right? So this is working pretty well. The only thing we need to do now is to dynamically blend between these two curves. And we don't actually need to do any math with it because there's a magical node called mixRGB, and it can perform operation based on just a numerical value, right? It's just 0.5 or 0.2 of your choosing. And this helps us blend between this XYZ data of curve A and curve B. So let's plug it in there and replace the position and see what does it do. Okay, at 0, we are mixing in 0% of the second set of attribute. We're using 100% of the first set of attributes, right? Because XYZ RGB is the same thing. So with factor 0, you see our baby curve, a new one. It snaps strictly to the first set of position. It has no awareness of the second curve. But if we put it to 1, this vector, and now you see the baby curve fully mixed in the second set of positional attribute, which comes from curve B, right? So it is exactly the same of curve B. And by simply toggling this factor, let me turn off the annotation. Yeah. You see this is dynamically blending in between these two curves nicely. And if we so decide to edit the two source curve outside, right, like your hair system, you're changing it, or your row system, right, I want to actually point it to a different way. No problem, the geometry node will dynamically match and generate a new result. So our work is done here. It's just for a little bit of housekeeping. Let's make sure it is more user-friendly than it is right now. Because if we want to swap curve or change the factor, like how far is it from A or B, or if we want to change the smoothness of this, right? Then we need to go back to the node, which is kind of annoying. We can make it more user-friendly by exposing those variable or options to the Modifier tab. And it's quite easy to do so by plugging it into the group input, right? So as you see, the moment I plug the object slot into the group input, I can now change it here in the modifying tab. So before it gets too confusing, we should also name this slot. So the one we plug in curve A, we will call that exactly curve A, and the one below it is curve B, right? So we're not confused. And in amount of sample, right? Currently, by default, we're cutting it 10 times, but depending on the size of your look or your desire, maybe it's not smooth enough. Or if you have 10,000 of these children in the scene and you figure, oh, 10 is too high, let's lower the poly count a bit, right? So we can control this with a value. Okay, let's keep it at 10 so we have consistent look. And actually, we are resampling 3 different curves with the same value. So now we can control all 3 resampling with just one value. Right? If I put it to 9 or 5, see it's getting gradually lower res, or if I'm 16, now it's way smoother than before. What we can also do is take this value and plug it into the input, right? This case, we also have the option to control the smoothness of the curve. Now it disappeared because by default it's 0. Let's put default back to 10 and minimum to 1 because not doing anything if we don't cut it at all. Oh, sorry. Minimum, let's do like 3 because you need the end, the middle, and the start, right? So at least you have a 3-point curve like that. Update, that makes sense. So we will also name this parameter like curve resolution, right? Because that's what it's doing for us. And we set it to 3. Like as we mentioned, at least you need 3 points to create a curve. Otherwise, it's just a straight line. But by default, let's put it to 10, and then like you see, it's functioning, right? We're adding to the smoothness or reducing the section so that we can optimize the curve. So this is how you can create a curve of resolution of your own desire, but the last variable we want to expose is this factor, right? So we can again drag this factor all the way back into the group input. And that way we can call it like the AB blending. Yeah, let's call it like that. So when it's 0, it is fully A. When it's 1, then the shape is fully B. Now we have recreated the setup I showed you in the beginning. And if I bring back that 1, yep, there you go. You see it's identical, right? We get to choose the blending and the resolution, and we can actually see a variation of this tool. I created a variation that supports multiple children. For example, If now we're set to 2 children, and we can put 3, 4, 5, and we can change the resolution, right? 2 is a straight line, 3 is a curve, then get it as smooth as you want. So this variation is also available on my gumroad if you're too lazy to plug it out yourself. The link is in the description below, so hope it helps you and have fun playing around with Geometry Node. Cheers.